MS-21. Range reduction, the weight of domestic composites. Last week, a document landed on the desks of Russian aviation officials. What they read sent a shockwave through the entire industry. The MS-21, Russia's answer to the Boeing 737 and the Airbus A320, had just lost over 1,200 kilometers of range overnight. The question wasn't if something had gone wrong, it was what. The answer: it turned out to be heavier than anyone expected. The figures painted a stark picture. The range of the fully domestic MS-21-310 plummeted from 5,100 kilometers to a mere 3,830 kilometers. This was no rounding error. It was a fundamental problem, and engineers knew exactly where to look for the mass. Vadim Lukashevich, a former Sukhoi design engineer, was unambiguous. Domestic composite materials were to blame. While Russia achieved outstanding results in producing these materials under sanctions, there was a catch. They were significantly heavier than the Western composites they replaced. How much heavier? Try 3 to 5 tons. In aviation, every gram matters. A few hundred kilograms can impact fuel consumption, rate of climb, and even route profitability. But several tons, you cannot hide that. You cannot ignore it. For comparison, 5 tons is roughly 50 passengers with their baggage, 50 paying customers, or the fuel required to carry them across continents. The MS-21 suddenly faced an impossible choice. This is where the discomfort for airlines begins. Since the aircraft's maximum takeoff weight did not increase, engineers were trapped. They could configure the aircraft to seat 170 to 175 passengers and live with a reduced range of 3,830 kilometers. Or they could restore the original 5,100 kilometer range by removing 25 to 30 seats. Neither option is palatable for airlines. Fewer passengers mean less revenue per flight, and reduced range means fewer available routes. This was not a minor issue fixable with tweaks and optimizations. It was a structural flaw built into every composite panel, every wing spar, and every structural beam. And it all boiled down to one thing: the composite materials themselves. With the introduction of sanctions after 2022, Russia lost access to the advanced carbon fiber materials that made the MS-21's wings so revolutionary. Developing new materials from scratch meant starting over, designing new fiber production technologies, resin chemistry, and curing processes. They succeeded, but perfection takes time. The domestically produced composites were denser, slightly thicker, and less optimized. The fiber-to-resin ratio wasn't perfectly ideal. The curing wasn't as uniform. And in an industry where grams count, these differences compounded across hundreds of components. By the time the wings were assembled, the penalty was unavoidable. What does this mean for the future of the MS-21? Practically, the aircraft is now best suited for internal Russian routes, most of which range from 2,000 to 3,000 kilometers. It is fully serviceable. But international flights to Europe, Turkey, and the Middle East, those longer routes, become problematic unless you are willing to sacrifice passenger capacity. And there is another issue lurking beneath the surface: fuel consumption. A heavier airframe burns more fuel for the same distance. In an industry where profit hinges on fractions of a percent of fuel efficiency, that extra weight constantly erodes the financial performance. Maintenance costs may also increase over time, as the heavier load puts more stress on the landing gear, wing structure, and fuselage attachments. Compared to the Airbus A320neo or the Boeing 737 MAX, the MS-21 now has a competitive disadvantage that cannot be explained away in sales pitches. But here is what makes this story more than just a cautionary tale of engineering compromise. Russia did not choose this path, it was imposed. After 2022, Western suppliers vanished. Continuing the MS-21 program with foreign components became impossible. Developing domestic alternatives was not a matter of ambition, but of survival. What other nations spent decades perfecting, Russia had to recreate in short order under pressure and with limited resources. The increased weight is not a failure, it is a starting point. So what happens next? The road to redemption is long, but it exists. First, Russia needs to mature its composite manufacturing: lighter fibers, better resins, and more modern production. This will not be solved in a year. It requires sustained investment, research, and industrial development. Second, structural redesign. Engineers can optimize individual components to shed weight without sacrificing strength. This is time-consuming and requires recertification, but it is possible. And third, operational adaptation. Airlines could operate two configurations: high-density versions for domestic hops and lighter, extended range variants for international routes. Not ideal, but workable. Over time, as domestic technology evolves, the performance gap will shrink. The question is not if the MS-21 can compete, but when. Because here's the big picture. The MS-21 proves that Russia can build a modern airliner entirely with domestic components. This is no small feat. It is a declaration of industrial sovereignty. The first version may be heavier, but it also carries something more valuable: proof of concept. Proof that independence, even imperfect independence, is achievable. The MS-21's range reduction serves as a reminder of the complexity of modern aerospace engineering. It is also a testament to the lengths countries will go to preserve their autonomy. Right now, that extra weight speaks not of failure, but of resilience, of an industry rebuilding from the ground up, one composite panel at a time. The MS-21 may not be perfect yet, but it flies. And in aviation, that is where every revolution begins. What do you think? Can the MS-21 close the gap with its Western competitors, or will the weight penalty define its future? Share your thoughts in the comments below. If you found this story fascinating, hit the like button and subscribe for more deep insights into aviation engineering and geopolitics.